Good evening, all. We are going to start the session now. I think our lecturer is ready, Professor Madhusankaliyanige. First of all, thank you very much, Professor, for accepting our invitation to share your thoughts and ideas and your findings on this area. We all know that you are a veteran and a key person who is working in this 5G and 6G area uh, in terms of research and practical application. So we thought of starting our telecommunication discussion uh, from this session. So we have conducted couple of discussions in power sector. So this will be our fourth guest lecture that is going to be uh, on air today. So Electrical, Electronic and Telecommunication Engineering Section Committee is very much pleased to welcome Assistant Professor Madhusankaliyanige for this session. Let me introduce him to the audience and I will hand over the floor to him to conduct this session. Madhusankaliyanige is a senior member in IEEE, is an assistant professor and adjunct fellow and director of graduate research at the School of Computer Science, University College of Dublin, Ireland. He is leading the network softwareization and security labs at the University of School of Computer Science, which mainly focuses on the security and privacy of future mobile networks, including 5G and 6G. He is also acting as an adjunct professor at University of Oulu, Finland, and the University of Ruhuna, Sri Lanka, and the University of Sri Jayawardenepura, Sri Lanka. He received his Doctor of Technology degree in Communication Engineering from University of Oulu, Finland in 2016. He was also a recipient of prestige Marie Curie Actions Individual Fellowship and the Government of Ireland Postgraduate Fellowship during 2018 and 2020. In 2020, he received the 2020 IEEE ComSoc Outstanding Young Researcher Award from IEEE ComSoc. In 2021, 2022, and 2023, he was ranked among the world top 2% scientists in the list prepared by Stanford University, USA. So the Dr. Lianage's research interests are 5G, 6G, blockchain, network security, artificial intelligence, explainable artificial intelligence, federated learning, network slicing, Internet of Things, and multi-access edge computing. So he's during his short period of research and academic career, he has done a lot to the field. So we are very much pleased and honored to have him today for our discussion. So without taking much time, I would like to hand over the floor to Assistant Professor Madhusankaliyanige. Over to you, sir.
Okay, thank you very much, Dushanta, so for the nice introduction and also inviting me to deliver this talk. I wish I could have been there to deliver this in person, so but uh, with the busy schedule, so we cannot find that kind of opportunity. So anyway, so it's a pleasure to address you guys in this talk, and this is the first time I'm addressing this IESL group. And today I'm going to talk about 5G security. So this is some kind of research work we started maybe around 10, 12 years ago. So how we can adapt how we can design the 5G network and what kind of technologies will be important. And I was mainly looking at the security aspect and what we can expect in the 5G networks and when they are designed and also deployed. So this lecture I'm trying to cover these ideas, but I thought not to go deep into the research work because it might be too advanced for some people. But if you are interested to know more details about the research work we are doing, and I'm happy to discuss after the after the talk what the more details about that. So yeah. Uh, So a little bit about my research team. So I'm leading this network softwarization and the security laboratory. So which is based in Dublin, University College Ireland. But it has branches span on the multiple universities. For example, like we have members from University of Palo Finland and also the members from University of Sri Jayawardhanapura and also from industry like Nokia, Rivario, and those areas also there are some members who are participating in this network softwarization lab. And what we are mainly focusing on the security and privacy of the future mobile networks, especially on the 5G and 6G area. So these days we are heavily working on the 6G network, what we can expect beyond the 5G network. And there are three teams actually we are working on the network softwarization and security automation. So today's talk mainly on this pillar actually, the network softwarization and the security automation area. And the second one is AI security and privacy, mainly on the federated learning and explainable AI domain. This is where we are working more on the 6G domain. And then the third pillar is the blockchain and how we can use blockchain in the mobile network to address different issues. So we started this group like 5 years ago now. We have grown exponentially actually. We have more than 20 members in our group. So we are rapidly growing with new projects coming into the research team. And for the moment, we are running three European Union projects on the 6G and AI domain. These spatial projects, the confidential 6G and the robust 6G. So these are mainly focusing on the AI security and also the 6G security. And in addition to that, we are involved with a couple of other projects like ML Labs, Connect, where we got the local funding. And also I'm part of this 6G flagship project, which is at the University of Oulu. This is like the 6G flagship project is the world very first 6G project we started in 2018. And so we are working heavily on the 6G domain for the moment. And in past, we have worked on different 5G related topics like Inspire 5G, 5G Champion, Sigmona, and these are mainly focusing on the security of the 5G area. And also we have a lot of research collaboration with different partners. So we are heavily involved with the industry. So most of our research more towards the applied research than the more theoretical one because we are working on the 5G and 6G domain. So that's why we are collaborating with the key partners of the from the industrial domain, and also we are participating with the different standardization organization like ITU, EE&TESC, ENISA. We are contributing to the different working groups, and also we, of course, we have collaboration with the academic partners across the within the Europe and also the outside of Europe. So that's mainly about our research group and what where we are standing for the moment. Now I am moving towards the today's topic. So the today's topic I have divided into three different areas. The first part is about the introduction to 5G, to discuss what is 5G and how it has been developed. And the second part is about 5G security. So basically, I have divided it to four different categories like pre-5G security issues and how it will be impact on 5G. Then what is this network softwarization and why? What are the new security issues arising with that? And then we will discuss about the new technologies which is used in 5G and how it will be impacting the overall threat landscape of 5G. Then the last one is the security issues related to the new verticals, but I'm not going to discuss more about this because then it will be too much work content for today. But I will lightly mention that. But then the third part is about the softwarization for the 5G security because the introduction of this network softwarization and the new technologies in 5G can also help us to improve the security and privacy of the 5G network, especially address some of the issues we found in the previous generation of mobile network. So let's start with the introduction to the 5G. So we know the evolution of the mobile network happened over the last 50 years with the different generations. So we start with the first generation mobile network mainly on the analog telecommunication. The second generation we got the digital communication and also the first data services like text messaging. The third generation is important because that was the first time we have introduced the internet connectivity via mobile network. And 4G, the main advantage of 4G was to introduce the IP-based communication. All IP-based communication was introduced in the 4G network. And now we are stepping toward the 5G mobile network. The first 5G network introduced like a couple of years back, and this 5G network rolling across the world very rapidly. And 5G is mainly about how we are connecting IoT type services and also supporting the network optimization based architecture. And when we talk about the 5G, I would say 5G is a complex ecosystem. It's no longer a mobile network. We cannot consider 5G as a simple mobile network anymore, because before 5G, like pre-5G network, we mainly talk about interconnecting mobile users and mobile devices. But 5G is going one step further. Actually, the last phase of 4G is already started this direction. We try to interconnect more and more IoT devices. We are not just focusing on the mobile devices. We are now connecting the IoT devices. So that is like one of the new thing which is coming with 5G, because it will be interconnecting IoT based services. So when we are interconnecting IoT based services and 5G becoming the main infrastructure for the IoT devices, that will expand the scope of a mobile network. Now we have different areas the mobile operators try to provide services. It can be like a smart wearable or smart mobility, autonomous driving vehicles kind of scenarios, or supporting the smart grid areas, supporting the energy sector, or if it is providing the connectivity for the wearables and medical IoTs, then it covering the healthcare section. So that means the 5G is expanding beyond the mobile network to day-to-day life application. So that's why I'm telling the 5G is becoming a complex ecosystem than just a mobile network. So this is just the expectation, like how 5G will be look like in coming years. So it is going to be a trillions dollar industry in coming years. It will be addressing the different marketplaces: energy, manufacturing, public safety, healthcare, transportation, entertainment, automotive, finance, retail, and agriculture. You can see it is touching different markets, and basically uh, all the areas are part of the human life. And also 5G will be introducing new applications like autonomous driving cars. Especially nowadays, autonomous driving cars are rely on the on car computation. The 5G can support the car to vehicle kind of communication, and also offloading the complex computation tasks into the mobile network. That will reduce the cost of autonomous driving cars and speed up the deployment of autonomous driving cars. And also it can support the drone based services, the food delivery, even the transportation can be support with the drone, and more and better video services, especially support 4K videos wherever possible, and also the possibility to support even 8K type of videos, and support new application domains like holographic TV, augmented reality, and mixed reality applications. and also support in this remote surgery type of scenario. Because, for example, like the remote surgery is a new, not a new application. It was discussing for the last 20 years. So one of the difficulty, we were not able to satisfy the latency demand for the real deployment of the remote surgery. So 5G is one technology which can satisfy this communication requirement, especially the latest requirement to enable this remote surgery and support industry, especially this industry 4.0 scenarios, and also support more and more wearable based devices directly connected to the 5G network. And how we can achieve this application to in order to do that, actually we need to go beyond the capabilities of the 4G mobile network. So we have a certain expectation where the 5G should be support. So these are the 5G requirement. So the two main requirement I would like to highlight. The first is the latency requirement. So from we want to go from about 20 to 10 millisecond latency supported by 4G to 1 millisecond latency with the support of 5G. And also the data rate is going to be increased. So the maximum data rate 4G can support is it's 1 gigabit per second, but in reality it support maybe like 400, 500 megabit per second. And with 5G, we try to achieve about 20 gigabit per second type of scenarios. And also the user experience data rate to up to 100 spec. And in order to support this IoT type scenarios, we need to have better energy efficiency and also more connection density than 4G network. So basically, these requirements, I won't say we have already achieved this requirement by the time we are deploying 5G, but eventually we are reaching to these goals with the development going on the research and also in the deployment side. And we have find out few enabling technologies in order to support that. So especially when we talk about the 5G network, it's a wireless technology. So there are many wireless or radio technologies will be supporting in order to satisfy this requirement, like new spectrum, massive MIMO technology, multi connectivity, flexible frame design or distributed architecture. So all of these technologies will be integrated in the radio side in order to support these requirements. But when we talk about the 5G, it's not only about the radio technologies. We need to have upgrade in the core network side as well. So I'm mainly focusing on the core network side design and what is the new things happening in the core network side. And this research this talk is also focusing on the core network design and the security issues related to that. So what is the biggest change happen in the core network side? What is the new thing happen from 4G to 5G? So that's very interesting to understand. So when we look at the 4G mobile network, so basically it has the hardware-based architecture. That means you have the proprietary hardware appliances with proprietary software that will be used in order to design and deploy a 4G mobile network. You have particular hardware boxes. It can be MME, HSS, OS gateway, or P gateway. There are different components which are hardware component, proprietary hardware component, which you need to buy and install in order to deploy your 4G network. And it will be a distributed hardware network, and which is has less flexibility and also less ability to support on demand dynamic traffic we are expecting in the 5G network. So how we can tackle this? So we are moving towards a new architecture or we call this as a network virtualization or network softwarization. So we are, instead of going to a hardware based system, we are going to a cloud-based architecture where we don't have any dedicated hardware. What we do is here, we pool all the hardware resources as one hardware pool. And on top of this hardware, we are going to deploy a virtualization layer to support the virtual resources. And all the hardware components we will be deploy as a virtual network function in the cloud, so we can download them and deploy in the virtual resources in the on demand basis. So we get rid of this hardware based architecture. We are going to a more virtualization supported architecture. That is the biggest change we have seen from 4G to 5G in the core network side. So we started moving the core network of the mobile network into this virtualization concept. Now we are doing more research on like how we can also support this in the radio network side. If you came across like the cloud RAN or open RAN kind of scenarios, basically moving looking at this area. So this network softwarization is one of the most important aspect and how the 5G network will be deployed. So this is really important that the moving towards this 5G mobile network actually based on the network softwarization has a lot of benefits, like it has reduced the cost of deployment, it provides more flexibility, so we can dynamically change the features of the network. So in order to achieve this kind of dynamic environment, actually, there are four main technologies is supporting. So I would say they are the four pillars of the 5G network when you consider about this network softwarization concept. One of these technology is the software-defined networking. The second one is network function virtualization. And the third one is the multi-access computing. And the last one is the network slicing. I will go through these technologies, some details in the coming slide. And these four technologies actually help to design this network softwarization in 5G. And also the transition from traditional mobile network, this hardware-based system to softwareized 5G network, is also happened on the phase by phase. In the first phase, actually, we were looking at like how we can enable this virtualization, the cloudification, especially how we can move this hardware-based network function to the virtualized network function. That was done using SDN and NFV, especially the cloud-based computing scenario. Then we focus on the second phase, how we can enable this service migration, especially from cloud to the edge or between the different entities. So we were looking at this service migration in the second phase. And the third phase is more about like how we can provide the orchestration, especially end-to-end service deployment, be done with the new technologies. We were looking at the third phase. And the fourth phase is more towards the service network automation, network slicing, and multi-access computing supported on this service network automation, especially to support the different application. How we can use the 5G is based on this network slicing and MEC technology. So this basically covers the introduction to the 5G. What is the 5G? Now you understand like what is the main differences between 4G to 5G and what kind of changes happen. Now we go and look at like what are the key security issues associated with the 5G network. So the evolution of the mobile network landscape is also very interesting to look at, because the mobile network has been vulnerable to different type of attack, especially the development of the mobile network in the each generation was the reason for that. For example, if you consider the first generation of mobile network, it was analog communication, as I mentioned. That means there was no encrypted communication. So basically, it is vulnerable for the simple eavesdropping attack or physical fraud attack, because there was no security whatsoever deployed in the first generation of mobile network. And the second generation, actually, we introduced the digital communication and some kind of security mechanisms to protect against this eavesdropping attack. But then we have introduced a new services like SMS services that will be leads to have a new landscape of security issues like spamming attack. In the third generation, what we did was we introduced the internet. We interconnect the mobile network with the internet. Now the mobile network become vulnerable for the different security issues which are originating from from the internet, like viruses, spyware, malicious applications. Those kind of things become a part of the mobile network. And what happened in the 4G, actually, 4G has further improved the integration with the internet. In addition to that, we are now having more and more powerful mobile devices. So we know some of the mobile devices have more capabilities than what we had in the server a couple of decades back. That means attackers are now using the mobile devices to attack the network. That was like one of the biggest issue we found in the 4G network, like mobileware attack, adverse persistent attack, or distributed denial of service attack were possible with the mobile devices. And what is happening in the 5G actually. So in 5G, we are now integrating the IoT devices. So that means the IoT based services getting targeted by many of the users, especially now it's not only about attacking the mobile network. Now it is more about attacking the national critical infrastructure. Maybe a healthcare system or transportation system can be attacked via the 5G network. So it can be also playground for the terrorists and also for the cyber warfare. So these kind of new security issues is arising with the 5G. And let's look at this composition of 5G security. Actually, I can categorize these security issues into four different areas. So the first one is the pre-5G security issues which are already existing in the 4G network might be impacting on the 5G. And the second one is the security issues related to the network softwarization. The move from the hardware-based system to the software-based system will introduce a new set of security issues. And the next one is the new security issues related to the new technologies. I have mentioned we are using different new technologies like SDN and NFP. They have their own vulnerability. Now they are become a part of the 5G network as well. And then the security issues related to the new verticals. That means like the new services we are enabling, like augmented reality application or autonomous driving. They have a new set of security issues, and that is also part of the 5G network. So we can classify them into four categories and look at what those issues. So let's start with the pre-5G security issues. I think most of these security issues I have mentioned are already people has been aware and maybe experienced in the 4G or even in the 3G domain. But these kind of security issues becoming more challenging in 5G domain in multiple reasons. So let's look at the first one is the mobile attack. So we know like the every day the capabilities of mobile devices are increasing. That means the impact of the mobile attack, like those botnet and APT attack, become more severe in the coming 5G network. And also the physical layer attacks, like attack in the radio network, like jamming in signal interference, eavesdropping, man in the middle attack. Those attacks will also becoming challenging in 5G, especially when we have more and more operators who doesn't have enough security personnel to support uh, the security. So of the radio network will be becoming more susceptible for physical layer attack. So the roaming fraud and IP hijacking attacks, so those attacks related to the roaming scenario. So we know the roaming is usually happen when you are going from one country to another country. But in 5G, there is a new interesting thing happen because I have mentioned the network softwarization is supporting a low cost deployment of the 5G network. For example, you don't need to be a mobile operator to deploy a 5G network because you can now download the open source 5G core network. You can install that in a Raspberry Pi and you can run a mobile network by yourself. So that easy to deploy a 5G network because of this network softwarization. Actually, that support a new set of operators. We call them as a private 5G operator or local 5G operators. That means uh, a, a places like university or hospital or factory. Actually, they can create their own 5G network and they can operate if they have the license to operate in that particular area. Because that is possible, the deployment of the 5G network is now cheaper and also it has the better performance than whatever the Wi-Fi or other LAN technology. So this is becoming a very interesting area to support these local 5G operators or private 5G operators with the 5G. So when you have more and more these local 5G operators deploy in the country, you can have the roaming instance happen inside the country as well. For example, you are the main operator, you are going to university, you can move from one network to the other network even within the same country. So that means the roaming now not only happen uh, between the country, within the inter-country roaming will be also possible. So during the roaming scenario, there can be a different frauds happen, like this IP hijacking, for example, that kind of roaming fraud. That means while you are returning the IP address, so somebody can hijack this IP address and they can use the services on the expense of the attacked person. So this kind of attack now even possible in this local 5G operator scenario. And the rogue base station attack. So, I mean, this is also came with the 4G. Actually, we were introducing some kind of femtocell and a small cell kind of base station, which will be deployed even inside the building. So, these kind of base station can be easily vulnerable for the physical attack. Somebody can physically access the base station and steal some of the information. Usually, these base stations have the cryptographic keys, which is need to register with the network. So those kind of information can be extracted from the base station and as a uh, pretend as a base station to attack the network. So these rogue base station attacks are becoming uh, more severe in 5G scenario because we are going more and more this small cell deployment in order to support more users. So this catch attack, especially hijacking the mobile traffic, especially tracking. This is more like a privacy attack. Try to track the local users. That is also possible in the 5G, and also attack via non-3GPP network like Wi-Fi, WiMAX, CDMA. When you are integrating these technologies with the mobile network, they probably doesn't have the enough security. So this network can be used in as an entry point to the attack the network. So these issues will be applicable in the 5G as well. Okay, so the second set of security attack is the impact of the network softwarization. The introduction of the network softwarization will have several new security issues. The first one is the open architecture introduced more attackers and also no implicit security due to lack of know-how. Actually, these two attacks going together. So what does this means? For example, when you consider like the 4G networks, 4G network was a very complex architecture. You need to know a lot of protocol in order to operate the 4G network. So not everybody know how the 4G network is working. So that means if you don't know how the system is working, you don't know how to attack it. So that means that make implicitly your network is secure because the people doesn't have enough know how to attack the system. But in 5G, we have get rid of this complexity. Now we have an open architecture, which is very easy to understand for anybody. That actually invite more and more attackers to attack the network. We don't have the implicit security which we had in the 4G network. And then we have the software-based uh, system. So they are typically easier to hack than the hardware-based system. Actually, this is also related to the fast deployment of this software-based system because we know if you can update the system very quickly or using software system, so you don't need to do a lot of proper security testing because you can remotely update the software and deploy it. So that due to that there can be a security vulnerabilities the attackers can exploit before the developer. But if you go for the hardware-based system, they have to do a lot of testing because once you deploy the system, you cannot go and change this. So that's why you are doing a lot of security testing to ensure the system is secure. So usually we believe hardware-based system has better security testing and the security protection than the software-based system. And the third one is the no perimeter security or the physical security due to virtualization. If we consider the 4G network, we know where the core network is located. You can put the security parameter around it and you can protect these these important devices, physically protect these important devices. But the virtualization, we don't have that opportunity anymore because we are now using the cloud resources. Unless the mobile operators use their own cloud, we don't know where these cloud resources are located. Maybe it can be in the enemy's location who can steal some of the information. So not having this physical perimeter will also impacting on providing this physical security. And then I'm going to look at this third section is the new security issues introduced by the new technologies like SDN, NFV, MEC, and also the network slicing. So what is SDN means? So SDN is the new technology which is introduced for the data network. It's not specifically designed for the mobile network. It is designed for any network, even the data network. So what the rationale of this SDN or software-defined networking is it is removing the control plane of the switches or the routers and put it into a centralized controller. So in the traditional network, we have the control plane and data plane in the same device, but in software-defined networking, you have the control plane deployed in a centralized SDN controller, and you have only the data plane in the routing or switches. So this separation of the control plane and data plane will allow you to reprogram the network, and we will have the programmable switches and also programmable data network. So this introduction of SDN will have several security issues. One of the security issues, obvious security issue we found is the centralized controller. So when you have centralized controlling over the whole network, it will become a honeypot for the many attackers, and also it becomes a single point of failure if there's an attacker successfully attack the controller itself. And also this controller is communicating with the rest of the switches via the southbound interface. We usually use open flow protocol for this communication. If you basically attack the southbound interface, it will be also eliminate the control, disrupt the control of the whole network, will have a big impact on that. And also we will have application layer plane where you will be deploying different routing functions and also application to control the network. These applications will be deployed in a cloud, which is provided by the different third-party application providers. If you don't have a proper trusted mechanism, this can be also impact the overall performance of the SDN network. So basically, these issues will be becoming part of the 5G network where we need to address. And the second most interesting technology we use is the network function virtualization. So this is actually what we use in order to support this network softwarization in the 5G network. What is NFV means? So usually if you consider any network device, you have the hardware component and also the software component to do the network function. So in the network function virtualization, we virtualize the network function. Instead of having them on board in the same hardware, we deploy the network function as a virtual network function in the cloud. So you can download and install whatever the network function in your hardware on demand basis. The separation of this network function and deployment of this network function as a virtual network function is called as a network function virtualization. So So this network function virtualization is supported by the HC architecture. So HC has been defined like how this NFV can be deployed in a network. So in this NFV architecture is vulnerable for the different issues. For example, in the NFV we have NFV management and orchestrator. We call it as MANO. So this MANO is responsible for the whole orchestration of the network function and also the service deployment. So they are vulnerable to different attacks like excessive log attack, for example. That means every network virtual network function has to provide the log information to the MANO, and it will be analyzing this log information to take the informed decision. So if the malicious virtual network function create in excessive amount of log, you can provide have like a denial of service type of attack on the MANO. And the privilege escalation attack, for example, like some of the virtual network managers, virtual network VNF managers can escalate their privilege and control the other VNF in order to do some harmful thing into the network. And there can be attack related to the virtual network function also. As I mentioned, this virtual network function will be developed by the different third-party vendor software developers. If you don't have the proper trusted mechanism, this VNF can be have adversarial effect on the mobile network. And the virtual machines, we need the virtual machine to run each virtual network function. So this virtual machine will have the typical virtual machine related attack like virtual machine migration attack, side channel attack, scheduler attack. So those kind of attacks will be also applicable in the 5G domain now. And the hypervisor can be get attacks, and then the whole virtual machine creation process will be jeopardized, and the whole network will be compromised in that scenario. So there are a set of security issues associated with NFE we need to be considered when the 5G deployment. And another important technology we are using in 5G is the multi-access edge computing. So this is a new technology because in order to support this low latency application, we introduced this multi-access edge computing, and we integrate the multi-access edge computing in the 5G network. So this usually we know the cloud architecture infrastructure. We use the cloud computing to use get some additional resources to deploy some services, but the cloud is placed in far away, and it will be very difficult to access them. So the multi-access edge computing, what they are proposing is like we are moving some of the cloud resources already at the edge of the base station, so we can do the cloud-based services already at the base station. So this idea is called as a multi-access edge computing scenario. So it can provide the storage, processing, and also the additional network services at the edge. So why we need the multi-access edge computing, especially in order to support these latency requirement and also the limit address the bottleneck of the backhaul connectivity. And it is also providing additional benefit in terms of security because we can now locally process these services using multi-access edge computing. So it will provide ultra low latency communication, location aware services, and higher capacity at the edge, and also additional security. I will explain why MEC is important in that area. But for the first, we have to consider like why the security is in the edge is important, because edge is the weakest ingress point uh, in the core network, because this is where the radio access network will be connected, and this is where the third party devices, or like the devices which are not under the control of the mobile operator, will be connected, like mobile devices, IoT devices. So they will be connected to the connected via RAN network. At the edge is the first place which is intercepted. So that's why the security is the edge is very important as the, and also it is the weakest ingress point for any attackers to attack the whole network. And the credibility of the IoT devices might be low, and then it will be also targeting the edge to enter the network. So the decentralization and the processing at the edge will also have impact, because now the people can access some of the data already at the edge, and the edge is not well protected at the core of the network, and then it will be also have serious adversarial effect on the network. The privacy and the integrity and the trust management is also important in the MEC scenario in order to support the better services. And also the make technology is using the virtualization technologies like NFE and also the cloud technology. So whatever the security issues applicable in the cloud and NFE scenarios will also apply in the make, and we need to consider that aspect as well. So here I have listed down some of the multi-access edge computing threat vectors. When we consider the make scenario, there are uh, services which are deployed at the edge of the network, and also there are services deployed at the core network as well. So most of these security issues I have mentioned in the NFV, like virtual machine related issues, VNF related issues, they will be directly applicable in the MEC scenario as well. Then the fourth technology is the most interesting thing is the network slicing, where which is very important to support the different type of services. So the network slicing actually came into the picture because when we need to support more and more mobile operators, it was more and more services. It is challenging to optimize the network into different service providers. For example, when we consider about IoT service provider, they need a massive connectivity. They want to connect millions of IoT devices. But if you consider healthcare operator, maybe remote surgery kind of scenario, they don't want to connect millions of devices, but they want to have low latency communication. If you consider about maybe a video service provider, they don't care about the latency, or they want more bandwidth, and how you can support more bandwidth for their services. So then optimizing the network for this each case is not possible. If you have only one physical infrastructure, optimize the network to each and every net demand of the application is not possible. So what is the best way to do is, like, you can have like separate network which is optimized for this application. But how we can have a separate network using the one physical network? This is where the network slicing idea came. So the network slicing idea, you can think it as a way to create a virtual network using a one physical infrastructure. So the network slicing scenario allow you to slice the physical infrastructure into multiple different slices, consider as a different virtual network, and then each slice you can optimize according to the requirement of the different application. You can, in this case, like this red slice can be optimized to support IoT, green slice can be optimized to support the healthcare with low latency, and the mobile broadband slice can be maybe support for the video application. So this network slicing concept help us to run thousands of different services in optimal manner on top of the 5G network. And this network slicing will also have different security issues like side channel attack. We have found very common in the network slicing, because if you don't, different network slicers has different security policies. Some of the slicers has well protected, some of the slicers are least protected. So if somebody get access to the least protected slice, they can access uh, do like the side channel attack for the highly protected slices, because one of the reason is like both the slices use the virtual network function deploy in the same physical hardware, for example. And the impersonation attack can be also possible. Some of the operators can impersonate and join the network slice do the attack. Denial of service attack is possible, because that means some of the slices overutilize the resources, then the other slices will be suffered, because We have only one physical resource, which is we need to share the resources with different slices. If one slice is overutilizing the resources, other slices will suffer from the less resources. That is become a denial of service attack. So stealing the information slice via the UE is attached to several slices. So that is kind of a bypass type of attack. If one user is connected to the two different slices, they can pass the information from one slice to the other slice. For example, the security information or the security credential that can be also used to attack the other slice. So there are this kind of attack we have identified, and it is become a critical issue in the 5G network. And then the security issues related to the new verticals. So there are different new verticals we can support: healthcare, autonomous driving cars, smart grid, wearables. So they have a different security requirement and the privacy requirement, and how and there can be different security issues also the way they are deploying at the network. But I'm not going to discuss these things because it will take a lot of time to discuss each and every application. And considering these factors, like how the 5G will be uh, vulnerable for different security issues, so we are defining different 5G security requirement which need to be supported by the 5G network. Especially this ITU has been already recommended a set of security requirement which need to be supported by the end-to-end service deployment. They can be divided into different areas like the user equipment level security, access network level security, core network security, and the application level security. So when it comes to the user equipment level security, is more about the protection against the mobileware based attack like malware support, side channel attacks, zombies. Those kind of attacks has to be uh, eliminated in the mobile end devices. And when it comes to the access network security, we need to define a certain level of security for the AI interface, some kind of coding mechanism or encryption mechanism, and the radio interface and the front hole and back hole security, so especially the authentication mechanism, and also the providing the enough security for the MEC and NFE and SDN and the cloud. All of these things are related to the multi-access computing scenario. So the providing the security against these attacks is important in the access network. When it comes to the core network, so we need to consider about the internet working security. So SBA is the 5G core network. We need to have a security on that regard. Network slicing is also related to the core network of the network, and the slicing security is important to be considered at the core network, and the cloud-based services is also relevant to the core network. And when it comes to the application plane, it's more about the big data security, web security, and the cloud security. And also we have identified the general security enablers which is need to be used against provide the security. So of course we have to use different cryptographic mechanism. Especially we had a thought of using this quantum safe cryptography, but still it's pushed back towards the 6G deployment because we know the quantum computers are not yet available. So still the quantum safe security cryptography is it's not needed at the 5G at the moment, but it's important to consider what are the post-quantum cryptographic mechanisms to deploy. And the security situation awareness, the awareness security is important because we are considering about the IoT kind of scenarios, and also these new technologies we have to consider like biometric based authentication, especially if you consider about this gadget free environment, and also deployment of the new technologies like blockchain, AI, and machine learning is also identified as a potential for the 5G security deployment, but still they are not really deployed in the 5G for the moment. At least at the research level, these things have been done. Okay, so far we have discussed only the security issues related to 5G, and uh, you might feel like, okay, using this network softwarization and the new 5G technologies will open open like a Pandora box of a lot of security issues will be arising. But not only that, this use of this network optimization and the new technology actually help us to improve the security as well. Actually, most of these security issues can be easily solved by using the capabilities offered by the network optimization. So the next part of the lecture, I will be discussing some of the way like how this network optimization can be used to improve the security of the 5G network. So here I have listed down 5 different scenarios like how this network optimization help to improve security. So one area is like the fast deployment and upgrade of the security mechanism. So the centralized security control and granular security management, optimize security resources and reduce the cost of security deployment. New ways of delivering security like security as a service using slicing or make technology and increase the scalability and the flexibility of the security services. So what is the fast deployment of the security mechanism means? So we have now get rid of using hardware-based services or hardware-based component in the core network of 5G network. So we can apply the same thing for the security devices as well. We are using a different type of security component in a network like firewalls, IDS, proxy gateways, those kind of things we are using in order to protect the network. So we can apply this virtualization concept for those things as well. So then we don't need the dedicated security hardware to deploy in the network. So you can already use already existing hardware to deploy these security services because now you need to deploy these security services as the virtual network function and you can deploy them on demand in the on the network. So and also the software based deployment is deployment and update are faster because in the previous case if you have like a hardware based security solution, if there's some attack, if there's a new attack came, maybe you have to replace the whole firewall system or intruder detection system. But in this case, you don't have to do that. You can easily do it with the software upgrade due to this support of this virtualization. So that's also one of the main benefit of this network optimization because you can deploy the security solution faster and also you can update them quickly. And also when we consider the beyond 5G technologies, so we have the distributed security. So most of the time we have a different set of security function deployed at the different section of the mobile network. So there's no coordination between these security scenarios. So distributed security is sometimes not working properly because it cannot be optimized to the better security services provision, and also it might be costly to deploy it, and also there can be a overlap in security services, which is we are not aware due to this distributed nature. But in 5G, we are supporting the centralized security management. For example, if we consider all of these 5G technology like SDN, we have SDN controller, NFE, we have Mano to support. It is also centralized control. Uh, make even though it's a edge computing, there is a core network part which is deployed the core network to manage all the MEC services. Again, it has a centralized management. Network slicing has a network slice manager to support the services. So all of these 5G technologies support in the centralized management that can be also used to deploy the centralized security control and also the policy enforcement, which is more optimized against the distributed technology. And optimization of the security resources and the reduced cost. As I mentioned, we don't need the dedicated hardware anymore. It will directly reduce the cost of security function deployment. And also we can optimize the network resources according to the on-demand requirement. So also we can time share the network resources with other services. The security networks services can share the resources with other services, that will be also reduce the cost of security deployment. And most interesting thing is the new ways of delivering security. So we know now we are connecting billions of IoT devices, and these IoT devices doesn't have the same capabilities as the mobile devices to deploy advanced security services. In that case, the IoT devices are vulnerable, and then we have to protect these IoT devices from the mobile operator side. So if you are going to protect these IoT services and provide the security services using the mobile network, we can use the new technologies to support that. For example, we can use the multi-access edge computing, and we can deploy the security services at the edge of the network in order to support this IoT security. And also network slicing is another example we can use. We can use the network slicing, especially maybe use like a different security slice in order to support the security for the IoT devices. So these kind of services like service security as a service can be deployed with the multi-access computing and slicing technology, which is a new opportunity for the mobile operator. And as we increase the scalability and flexibility, so that means we can easily dynamically scale up and or down the cloud resources in order to support these security services. That is also one of the benefit where this 5G will be introduced in order to support more scalable security services. So I think with that, I will finish today's lecture. So I have covered all three areas. So thank you very much for the attending. So I think it took about 1 hour. So if you have any question, I'm happy to answer. And also this is my email address. So if you have any question, you can also contact after the lecture anytime. I'm happy to answer.
Thank you, Dr. Madhusan Kalyanagi. I think we had a very productive session. He has extensively described the basic fundamental of 5G and the security concern of 5G, and how the security concept can be applied to optimize the network further. So we can allow a couple of questions from the audience. We have like more than 30 online users and couple of physical users as well. I have a couple of questions from our physical audience. So before that, I get you opportunity for our online users first. So if you have any question, you can raise from the lecturer.
Do we have a security standard for this 3GPP or 5G? Any standard like NIST?
Yes, yes, that's a good question. Actually, there are security standard already defined by 3GPP related to the 5G because when you're deploying these things or what kind of encryption mechanism you have to use, what kind of authentication mechanism you have to use, these things as well documented in the 3GPP standard. So if you want, I can direct some of these standards because I don't remember them by heart now, but there are standards already defined how to deploy these things, especially to address these issues. And also, when we consider about
So these
one second, and also like when we consider like a multi-access edge computing and NFP, that's also we have a standard defined by EE&TESC. So because they are the one who developing those things, there are a security standard defined for those technology as well. So we have to use the standard when you are deploying. Hello.
So I mean to say now we have.
I think there's a connectivity issue. I cannot hear you properly. Uh,
But we
Doctor, can you hear me?
yeah, I can hear you now.
Yeah. So, yeah, do we, I mean, now say, for example, now in IT security, we have SIEM solutions to install and, identify any suspicious attack like that. Any tools are there available to protect 5G networks and its related application, or it's sort of a built-in security coming into the picture?
No, actually, the security, there are some standard you have to follow. For example, like authentication protocols, or when that authentication protocol has to be supported by the mobile user when they are registering with the mobile network. So those things are like a standards already defined, and also like when you are doing some kind of wireless RAN network, what kind of encryption you have to use for the wireless BRS. So those things has been defined, and also core network, what kind of encryption you have to use. Those that is also defined, but it doesn't guarantee it will be protected against all the attacks happen in the 5G network on the runtime. For example, somebody can do some kind of DOS attack, or they can use some kind of uh, APT attack, or those things will be not protected from the standard. So in order to mitigate those attacks, actually we have to use, as a mobile operator, has to use their own security mechanism. So it doesn't comes directly with these devices, so you can deploy your own security solution in this case. In the 4G network, actually, you have to rely on the vendor, let's say the mobile device vendor, maybe Nokia, Ericsson, or Huawei. So they are the one who should provide the security solution inbuilt in your hardware. But in 5G, you don't have to rely only on the mobile operator. You can go for like a separate vendor who's developing this security solution, and you can use in your network. But it's definitely up to the mobile operator to how to provide the security services.
Yeah, thank you, Professor. Thank you so much.
Yeah. Any other questions?
Right, I will put some questions raised from the physical audience and something related
Okay.
from my personal interest as well. So, Professor, we basically discussed and identified that 5G is kind of a digitalization. The entire network, the core network, application, even the access is migrating from hardware platform to software platform. So, in this case, like digitalization basically remove the territory barriers. So if we consider a market like Europe, so how we are going to cope with, like I guess there are a lot of nearby countries. So in some articles we saw that the network operator can develop a one SDN or NFV for the couple of countries. So in that case, how those countries are dealing with security and how they are like doing interoperability, and what is their security practices and concerns when they are deploy 5G network?
Good question actually. So this is like the critical issue. So when you are using these cloud-based services, you don't have the physical barriers. So in this regard, actually, so there are some practices already defined by different countries. For example, US has their own one, and the Europe, actually we have the European Commission has been defined set of practices we need to deploy or adhere by the mobile operator. So one of the practice is like what we are saying in Europe actually. So the data of Europe cannot leave the Europe. So that means whatever the data data centers and whatever the cloud services we are using, they has to be within Europe. So you cannot use outside Europe scenarios. So that's like one way, like we can contain the information within a certain area. For example, if one country wants to keep all the services within the country's perimeter, so they have to deploy this kind of uh, uh, regulation. So the cloud services, of course, you can use, but the cloud farms, so the server farms has to be located in the same country. So in that way, actually you can confine everything in the same country. So otherwise, if the data is moving from one country to other country, if you are using the cloud services from the secondary country, there is always a threat. So the secondary country might not have the same level of security or same level of, especially the security, not the security, privacy is the critical factor, because we know like some countries, some region has strong privacy regulation. You cannot get some information without the consent of the user. But in certain countries, you don't have that kind of privacy right. So you can extract any information you want even without the consent of the user. So if the data is stored in that kind of country, you don't have the same level of privacy. So because that's actually important to address. That's why these kind of regulations are there. So the data has to be within the same, let's say like the same security levels. So for example, this virtual network operator scenario you have considered, which is operating in multiple countries. So again, then they have to satisfy the security requirement of each of the countries. If in the Europe, actually, it's not a big problem, because in the whole Europe, we have the same security requirement. In the most of the countries are following the European Commission security standards. So that's why we can have this kind of interoperability very easily. And if you want to have, it's beyond this country, so maybe we need to have some kind of agreement. For example, US and Europe, we have like safe harbor agreement to support these kind of services. This is like another example, like how we can support this interoperability.
Right,
Yeah,
thank you.
so
I have another question from the audience. So what it is saying that in the digitalization process, we saw that the industry that most benefited is power and utility sector. We saw that 19% impact is happening, changing power and utility sector. So if we are thinking about the energy efficiency of this network, do you specifically think that for 5G has given a solution for the energy efficiency in compare with 4G?
yes, actually, the energy efficiency has been considered like one of the main concern in the 5G development. For example, we are trying to reduce the energy utilization in many aspects. So one area is the radio communication. So we are using the low power communication in the 5G, the radio network, so that will be reducing the energy utilization. And also the core network side, we are now reducing most of the energy usage because of these cloud services. One of the area, like you don't have to run a lot of devices, because now you can optimize the resources use in the network. That will also reduce the energy utilization. And also there is another area that energy utilization will be improved is we are reducing the core network traffic. For example, if you consider like 4G kind of scenario, there are like 55% to 60% of the traffic is using for the control traffic. So usually you have only about 40% of the traffic available for the user communication. That's the main part of the network. But 5G, we have reduced that control plane traffic, so that also help to reduce the energy utilization in the 5G network. So those kind of approaches has been used. But honestly, I'm not working much on the energy side, so I can't comment like the more details techniques which is used in the 5G to support this energy efficiency.
Thank you. We have two more questions from the audience.
Yeah.
If I can say, we discussed about the Europe market, how we are going to deploy 5G in Europe market. If you think about the Asia market, Bangladesh,
Mhm.
Sri Lanka, Maldives, so most of countries are still enjoying 3G, in the maximum case 4G. So they have invested a lot in the network to develop in terms of hardware and the capacity building, server network building, and all. So what is the motivation for these countries to migrate to 5G? Because the 5G network is entirely based on software, virtualization, and digitalization. So they are within shortest period of time, they have to remove all the hardware and they have to go to a software-based network. So will they enjoy their return on investment of the network? So what will be their motivation for them to go to 5G at this venture?
Yeah, actually, that's actually related to any transition when we are having in the mobile network, right? When you are going from 2G to 3G and 3G to 4G, 4G to 5G. I mean, always this challenge is there because you have already invested a lot of resources in the previous generation technology. So this is not will be happen on over the night. This is like the gradual process. Like when you have like more and more users connected to your network, you might not have enough resources to support those things. So then you have to move from 4G to 5G. Otherwise, you don't need to change right away to 5G if there's no such demand to support those things. And also the need to use 5G is also arising with the user requirement, like the need to deploy a new application. For example, if autonomous driving cars is deploying, then maybe you need 5G. The 4G is not supporting. But again, that coming with the requirement from the user side. So I would say this is happening in the very slow phase and moving. Even within in Europe, it is not happening in the faster place. So what we do is like when there's a new demand is arising, we use the 5G network to support that. We will not invest more on the 4G network because it is going to be outdated soon. And one of the other area like 5G can be directly applied in the developing countries unless I mean the what I can see this private mobile operator sector it's very interesting because so there are many areas in the Asian countries, even in the developed countries, which which not yet covered by 4G operators because it's too costly to deploy. So in this kind of scenario, these private operators can be very interesting because it can be operating in the 5G in the regional level. This is easy to deploy, cost efficient to deploy. Sometimes the reason this 4G is not available because of the cost. In this kind of areas, the 5G can be a solution because you can easily deploy. And we have seen many use cases, this kind of private 5G operators already deploy where even you don't have 4G coverage. So that I would say like immediate benefit for the developing countries we can achieve from the 5G.
Right, I think topic is very interesting. We are getting more and more questions. I think there's another question. Is so 5G basically discuss about SDN, NFV, network slicing, and multi-edge computing. So in that territory, what is the impact of network cloning? Because the network is totally dependent on softwareization. So is it
Mhm.
in some case network cloning would be a security threat. In other case, the operator can be copy and paste network to reduce the network implementation cost and the development cost. So what role the network cloning is playing in this scenario?
Yeah, actually, that's a good question. So this the network cloning actually supporting to faster deployment of or maybe scale up the network very quickly. So if you consider about the security threats of that, so Yeah, so I can see like one of the benefit actually we are using this network cloning. It's not like the network cloning we call it as a like digital twin concept. Like for example, like you can create like a digital version of the whole network and see how it is operating. In these kind of scenarios, actually we can uh, uh, maybe like imitate some kind of security issues and also develop a solution without impacting the real network, because you create a digital version of the whole network and imitate the security attack and develop the solution, and you can do everything in the virtual world without impacting the actual network. So I think this kind of solution can be also applied in the digital coin as well. For example, if you find some protected network solution, so it can be directly used in this network cloning scenario as well. So, but other than that, I can't comment any negative effect of using in the security wise. What are the negative effect of the cloning? Maybe another issue related to the cloning, I can think about the privacy issues, because when you are cloning, some of the user credential might be uh, used, because the network patterns, how the users are using the network, those are can be like a privacy information, which can be also transferred during the cloning, and that can be also a privacy threat, I would say. So actually, it's an interesting area to explore and see what is the impact of the cloning.
Right. Thank you, doctor. So we are getting some chats in the box as well. So what is the policy? Let me see. Yeah, what are the responsibilities of SL government behind the 5G?
Uh, I'm not sure. Like the government itself is responsible. I think we have the Sri Lankan TRC, right? So they are the one who responsible for the 5G deployment, like especially defining the regulations, what kind of frequencies they can use, what are the security rules they have to use, what are the safety rules they have to follow, and spectrum management, and also the what kind of devices you can use in the 5G. So those things actually done by the TRC. I think they are the one who's mainly responsible for this aspect, in my opinion.
Right. Another question, sir. Will this 5G affect human brain or animal? I think it's related.
Okay, so this is related to the safety and the stuff. So I think there are some issues discussed, like when you are using new frequency band, it might have some effect on the human brain and the animal. So actually, this is uh, the thing is like the 5G is not going to replace the whole radio spectrum, right? So it is going to use the existing radio spectrum, which is used by 2G, 3G, and 4G for the last 50 years. So using 5G is not going to affect if it is operating in the same radio frequencies, which has been used in any in those radio frequencies, then there will be no effect, because it's the same thing we have experienced over the last 40 or 50 years. But when you think about like the new radio spectrum, maybe with higher radiation levels or something, then I think we have to use them in the confined environment. For example, if you are considering the factory environment where all the robots are communicating, in that kind of environment, maybe you can use uh, more like a high power radio frequency, then it will have effect on the human. But in that environment, if the humans are not working, then we can use it. So that kind of a environment we can consider. And also if we consider about the space communication or deep water communication, something we are looking at in the 6G era. So in that kind of spaces we can use the new radio frequency. But using 5G with the same radio frequencies will not have any different effect than the 4G or 5G. That's my answer mainly.
Thank you. I think we can have the last question from the physical audience.
Hmm.
Right. This is like, okay. There was some news in recent past that 5G affected to spread the COVID-19. And a lot of people think 5G is a spy machine of powerful countries like China, USA, and Europe. So I know that there is no theoretical backing or the technical backing for these concept, but it is coming from public users. How the 5G scientists or the 5G engineers going to face these challenges when deploying and implementing network in the practical scenarios?
I think this is like the conspiracy theories are there with any technological development. I mean, this doesn't have any ground or theoretic. I mean, scientific background. I mean, I don't see like there's a need to answer this kind of thing. It's just the conspiracy theories. So I don't see, I mean, any point on that. So, so those are like all the false claim. I mean, there's no direct connection with the COVID-19 and 5G. I don't know. I didn't find any single research justifying these things. So these are just some kind of imaginary concept or claims, as far I understand. So as long as they are not doesn't support with the scientific backing, we don't have to answer them. I mean, that's my opinion.
Exactly. Thank you. So if you don't have any questions from online audience, you can spare a couple of time.
Okay.
Right. I think we have come to the end of the session. I think we had a very fruitful session with Professor Madhusan Kalyanage. We got more than 5 to 10 questions from the audience, and we try our level best to give opportunities for everyone. And if you have any more questions, you can uh, direct through professor's contacts, email address, and other details are here. So on behalf of Electrical, Electronic and Telecommunication Engineering Sectional Committee, I would appreciate and I would say my gratitude for Professor Malshan Kalyanage. I think he has that intention and anticipation to support us, our Sri Lankan engineers and community. He was a proud product of University of Moroto and has climbed a big ladder during very short time. And I think he very recently awarded as the best scientist among world context. So we are very proud to have your have you today, and we are very proud to see your progress in world context in these 5G and 6G experiments. So since it is his first involvement in the ISL, and we are very much interested and keen on inviting him for future activities as well. If you visit Sri Lanka, we are very happy to have you in person for discussion and knowledge sharing session. So until that, we can say goodbye to you, and we are on behalf of ISL and sectional committee. I would say like the content you have added to the today lecture is very valuable, and very phenomenal. And this discussion will not stop here. We will have more discussions, and we will take your support and your contribution and involvement in future activities as well. Thank you very much, Professor Mansankaliyangi.
Thank you very much. So I'm also happy to contribute in future events. So thanks. Okay. Bye.
Thank you. Good night.